Hello team, in this video we're going to talk about network address translation, or NAT. So virtual machines on the cloud, they need identifiers. And in the context of the internet, identifiers are IP addresses. So here we have 7 virtual machines with 7 different IP addresses. So this is the ideal scenario. Each virtual machine has its own unique IP address, and then we can identify them very easily. And this is possible if we are using IPv6 addresses, because IPv6 addresses have 128 bits, so we have a lot of IP addresses available, and we can give one IP address, one different IP address for each virtual machine. So this is fine. Unfortunately, we also need to give 32-bit IPv4 addresses to virtual machines. And we don't have enough IPv4 addresses to assign one different IP address to each virtual machine. So what cloud providers do is they use private addresses, like addresses starting with 10 dot something, and they reuse IP addresses across multiple virtual networks. So what we have in the end is that virtual network yellow will have IP1 and then IP2, and then the same IP1 will appear in the blue virtual network, and IP2 will also appear on the blue virtual network. So IP addresses might be repeated and reused in different virtual networks. Now, one problem we have is actually identifying the virtual machines if we are, for example, on the outside of the data center. And the problem here is that these IP addresses are repeated. And another problem we have is that these IP addresses, they are private. So they are not routed globally on the internet. So these IP addresses, they don't make a lot of sense to a user, because the user has no context about this, local environment where the private IP address was generated. So here, if this virtual machine with a private IP address IP1 tries to send a packet to this external user, so even if this packet makes it all the way to the user won't know what to do with the packet, because this IP1 is private, so the user doesn't know where to send it. What we do instead is use a network address translation. So the virtual machine has a private IP address, and this IP address is shared with other virtual machines in other virtual networks. And then so when it sends the packet, we have this, IP1 is the source, and then we have a source port, and then we have the destination is the user, and then we have a destination port. So this packet will go out of the data center, right? So this virtual machine send a packet, the switch will receive this packet. So the switch knows that the destination of this packet is the user, and it's outside of the data center. So it doesn't need to do any VXLAN encapsulation, because the packet is not east-west traffic, it's north-south traffic. So instead of doing VXLAN, this switch can just rewrite this packet. So what it will do is it will rewrite the source IP address with the server's IP address. So this server has a public IP address, server 1, and then it will possibly allocate a different port number for the source port. So 7070 is one possible port. So we rewrote the source IP port from IP1 port 5050 to server 1 port 7070. And this packet is what we will actually send to the user. But before we send this packet to the user, we save this little mapping here. So this mapping is important. The virtual switch needs to keep track of this mapping. So we need to track that this blue packet was rewritten into this gray packet. And then we send the gray packet over. So it's going to go through the data center network, out of the border switch, and then into the internet, and it will make its way to the user. Now the user can receive, process this packet, and reply to it, because the source is a public address, the address of server 1. So this address is globally routable. The user knows how to send a response to this address. So the user will generate a new packet. So it's basically the same packet, but now we changed the source and the destination. So the destination is now server 1. So this is the packet going in the reverse direction. So the destination is server 1, port 7070, and the source is the user, port 6060. So this packet will traverse the reverse direction. It's going to go over the internet. It's going to arrive at the data center border. It's going to traverse the data center network, and it will arrive at server 1. Now, when it arrives at server 1 is not actually talking with the user. Right? So this packet is not destined to server 1. Server 1 doesn't know what to do with this packet, except that it knows that it's written, this blue packet into the gray packet. And then it can see that this dark gray packet is the response coming back in the reverse direction of the gray packet that we sent out before. So we will rewrite the gray packet into a dark blue packet. Okay, so now the destination, instead of being server 1 port 7070, it's going to be this destination here. So we're going to copy it over. So we're going to say that the destination is IP1 port 5050 on the blue VLAN. And then we send this packet to the destination. So the virtual machine can talk with devices on the internet even though it has a private IP address, because the private IP address is IP1 is rewritten with a public IP address server 1 when the packet is going out of the data center. And when the responses come back, then we rewrite the public IP address with the VM's private IP address so that the VM doesn't even know that this translation is going on. So the VM sent this blue packet and received this dark blue packet in response. So from the point of view of this virtual machine, it's like it's talking directly with the user. And in between, we have this network address translation so that we rewrite the private IP addresses into the public IP addresses. And a key component in NATS is keeping track of which private IP port pairs were translated into which public IP port pairs. So here we've translated private IP1 port 5050 into public server 1 port 7070. And when the response comes back, then we know how to translate back this public IP port pair into this private IP port pair.